Point 6.5 parallel lines and the transversal. This is page number 98 NCRT class 9. Recall that a line which means intersects two or more lines at a distinct point is called a transversal. See the figure 6.18. Line A intersect lines M and N at points P and Q respectively. Therefore, line L is a transversal for line M and N. Observe that four angles are formed at each of the points P and Q. Let us name these angles: angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8 as shown in the figure 6.18. So angle 1, angle 2, angle 7 and angle 8 are called exterior angles, while angle 3, angle 4, angle 5 and angle 6 are called the interior angles. Recall that in the earlier classes you have named some pair of angles formed when a transversal intersect two lines. These are as follows: corresponding angles, alternative angles, alternative interior and exterior, different type of alternate angles, interior angles on the same side of the transversal. So let us see on the board. Two lines are there. This is M and this is N. And this line L is intersecting both the lines L and M at P and Q. At P and Q, yes. At here P and here it is at Q. So the angle forms are here angle 1, angle 2, then angle 3, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. So there are 8 angles. So angle 1, angle 2, angle 7 and angle 8 are called the exterior angles, while angle 3, angle 4, angle 5 and angle 6 are interior angles. Now angle 1 and 5. Now angle 1 is equal to angle 5. And again one more pair is there. Angle 2 and 6. Angle 2 and 6. Angle 2 and angle 6. Again the pair will be 4 and 5. 4 and 8. Angle 4 is equal to angle 8. And 3 is equal to 7. Angle 3 is equal to angle 7. These angles are known as corresponding angles. Then alternate angles are also there. Angle 4 is equal to angle 6. Angle 3 is equal to angle 5. So these are the alternative angles, but interior angles. Alternative interior. Alternative interior angles. Now alternative exterior angles. One is equal to, okay. So one an alternative interior is given. Alternative 1 is equal to angle 7. 1 is equal to, yes. 1 is equal to 7. So angle 1 is equal to angle 7. Angle 2 is equal to angle 8. Angle 2 is equal to angle 8. So this is alternate angle. Alternative angle. Alternative exterior. Exterior angle. Okay, interior angles on the same side. And the interior angles, there are four interior angles, 3, 4, 5, 6. So 4 and 5, angle 4 and angle 5. These are the both are the interior angles of same side of transversal. And again 3 and 6, again 3 and 6, also interior angles of the same side of the transversal. So these are the angles of the intersecting line of two lines, given line M and N, intersected by a line L at the point P and the Q. Interior angles on the same side of the transversal are also referred to the consecutive interior angles. Interior angles on the same side of the transversal are also referred to the consecutive interior angles or allied angles or co-interior angles. So both the angles 3 and 6, 4 and 5 are known as the co-interior angles or allied angles or consecutive interior. Further, many a times we simply use the words alternate in the angle of the alternating interior or alternate interior angle. We can say the alternate interior angle. Okay. Now let us find the relation between the angles of these pairs when the line N is parallel to line N. If in this condition it is not given uh, that they are parallel or not. If it is parallel, in this condition you can put here 1 is equal to 5, 2 is equal to 6, 4 is equal to 8, 3 is equal to 7. Equal sign you can put. Earlier you cannot put. So for now let us find the relation between the M and N. You know that the ruled line of your notebook are parallel to each other. So with the ruler and the pencil draw two parallel lines along any two lines or two of these lines and transversal of intersect them as shown figure 6.19. Now measure any pair of corresponding angles and find out the relation between them. You may find angle 1 is equal to 5, angle 2 is equal to 6, angle 4 is equal to 8, angle 3 is equal to 7. Similarly, the alternate angles are also there. So from this you may conclude the following axiom. Axiom 6.3. If a transversal intersect two parallel lines, then each pair of corresponding angles is equal. If a transversal intersect two parallel lines, then each pair of corresponding angles is equal. Now this is the parallel line, you can say, and one line is there intersecting both the lines. Suppose this is you can say L and this is you say M, and this line is N. So intersecting points are there. So uh, if a transversal, this transversal line N is intersecting the two parallel lines L and M, then each pair of corresponding angles, one pair is here and second pair is here. So each pair of corresponding angles are equal. Axiom 6.3 is also referred to the corresponding angles axiom. Now let us discuss the converse of this axiom, which is as follows. If a transversal intersect two lines such that a pair of corresponding lines is equal, then the two lines are parallel. Does this statement hold true? It can be verified as follows. Draw a line AD and mark point B and C on it. Let B and C construct angle ABQ and angle BCQ is equal to each other as shown in the figure 6.201. Produce a cubic and SC on the other side of AD to form two lines PQ and RSC, the figure 6.202. You may observe that the two lines do not intersect each other. You may also draw common perpendicular to the two lines PQ and RS at the different points and measure them length. You will find the same everywhere, so you may conclude that the lines are parallel. Therefore, The converse of corresponding angles axiom is also true. So we have the following axiom.